Good day, guys, and welcome to the introduction for programming in C++. First session, part 2 of the Diverse Node Mobility Front-End Development Program. Today, we will continue to discuss Chapter 1 that talks about Introduction to Computer Programming. So I'm going to share my screen to you guys. Right here. So let's have your first program. Now we are going to show you a very simple program written in C++ language. We are going to use this example to present you some basic rules governing the language. The programming itself will be modified many times as it becomes enriched by various additional elements in expanding our programming knowledge. Ready? Alright, then let's go. First, we need to define our expectation for the program. They will be very modest. We want a short text to appear on the screen. Let us assume that this text will state, "It's me, your first program." That is all we want at the moment. What further steps does our first program need to perform? Let us try to enumerate them here. Okay, so first is to start. Next is to write the text on the screen. And third would be to stop. This type of structured and semi-formal description of each step of the program is called an algorithm. Sources of the word algorithm can be traced back to the Arabic language and originated in early medieval times. And for us, this represents the beginning of the computer programming. Now it is time to see our program. Here it is. So it looks like a bit mysterious, doesn't it? So let's check out each line of the program carefully and uncover its meaning and purpose. The description is not particularly accurate, and those of you who know a little C++ already will probably conclude that it is too simplistic and somewhat childish. We did this on purpose. We are not building Rome in a day, not even in a week. So let's move on. So I'm going to, if you are going to click this one, so it will prompt you to save the source file. So I'm going to create another folder here, and I'm going to name it C++ source code. Alright, so I'm gonna open this and save it. Okay, so if you are going to run that one, and let us run that one via or using the NetBeans. So we are going to click this. Alright, so all we need to do, if you already opened the Apache NetBeans, it will prompt you to the start page. And for us to open what we have downloaded, all you need to do is click the file and then open file. So here it will prompt you to a search box. So here, so you're going to search wherever you save that file. So in my end, I save it on C++ source code folder. So I'm going to click this and then open. So after you open, it will prompt you to the editor. So here it is still loading. Okay, so let us wait. Right, guys, so after loading, it will not give you or unable you to give the run button. Why? Because we have an error here. Or you can see that speech bubble maybe on the right or on the left. So the notification said install NBJ Java C library. So all we need to do is click that error, and then it will give you a recommendation solution. So click the link, and then the following plugins will be installed. All right, so we are going to accept and then install that. Okay, so that is a needed recommended plugin in order for us to run our program. After loading, you can restart the IDE now or later. But if you try to restart the IDE later, it won't give you any changes for now. But let us do it for restart IDE now. Right, so let's finish it. Okay, so it will restart our NetBeans, the Apache NetBeans. Right, so here, as you can see in the illustration, this is the code in our first program. So while waiting, let us move to the next slide. All right, our next slide is the continuation for the last slide. So pay attention to the character hash at the beginning of the first line. It means that the content of this line is the so-called preprocessor directive. So here, as you can see, the hash include, it is the preprocessor directive or the header. We are going to tell you more about the preprocessor later, but for now, we will only say that it is a separate part of the compiler whose task is to pre-read the text of the program and make some modifications in it. The prefix pre suggests that these operations are performed before the full processing or the compilation take place. The changes the preprocessor will introduce are fully controlled by its directives. In our program, we are dealing with the include directive. When the preprocessor meets the directive, it replaces the directive with the content of the file whose name is listed in the directive. In our case, this is the file name iostream. The changes made by the preprocessor never modify the content of your source file in any way. Any alterations are made on a volatile copy of your program that disappears immediately after the compiler finishes its works. So why do need the preprocessor to include the content of the completely unknown file codes iostream? Writing a program is similar to building a construction with ready-made blocks. In our program, we are going to use one such block, and it will happen when we want to write something on the screen. That block is called cout. You can find it inside our code. So here, so we use cout here instead of printf. Printf used for C and cout used for C++. But the compiler knows nothing about it so far. In particular, the compiler has no idea that cout is a valid name for that block, while CUOT isn't. The compiler must be warned about it. It needs to be aware of the fact a set of preliminary information that a compiler needs is included in header files. These files contain a collection of preliminary information about ready-made blocks, which can be used by programming to write text on the screen or to read letters from the keyboard. So when our program is going to write something, it will use a block called cout, which is able to do trick, or much more. We don't want the compiler to be surprised, so we need to warn it about that. The compiler's developers put a set of this anticipatory information in the iostream file. All we have to do is use the file. This is exactly what you expect from the include directive, but where is the iostream file located? The answer is simple, but not as clear as you might want. That is not a problem. The preprocessor knows where it is. Good job, preprocessor. So now let us check our NetBeans still loading. Okay, so let us continue to the next slide. Okay, so in the C++ language, all elements of the standard C++ library are declared inside a namespace called std. A namespace is an abstract container here, abstract container or environment created to hold a logical group of unique entities or blocks. An entity defined in a namespace is associated only with that namespace. If you want to use many of the standard C++ entities, you must insert the using namespace instruction at the top of each file. Outside of any function, the instruction should specify the name of this desired namespace, std in our case. This will make the standard facilities available throughout the program. So here uh, we add using namespace std before the main function. And after the std, we add semicolon. For the continuation of explanation of your first program, we have already said something about the blocks. Now let us go a little deeper. One of the most common types of the block used to build C++. If you associate a function with a mathematics, you are on the right track. Imagine a function as a block box where you can insert something into it and take something new out of it, as if from a magic hat. Things to be put in the box are called function arguments. Just like we have taught in C, inside the blocks are called function uh, arguments here inside a box. Okay, so things to be taken out of the box are called function results. In addition, a function can do something else or on the side. If this sounds rather vague, don't worry, we will talk about functions many times and in much more detail later. Back to our program, the standard of C++ language assumes that among many different blocks that may be put into a program, one specific block must always be present, otherwise the program won't be correct. This block is always a function with the same name main. Every function in C++ begins with the following set of information. First, what is the result of the function? Second, what is the name of the function? And third, how many parameters does the function have and what are their names? Take a closer look at our program and try to read it properly, accepting the fact that you won't yet fully understand everything. The result of the function is an integer here, integer value. We can read it from the word int, which is short for integer. The name of the function is main. This is the name of the function, and the function doesn't require any parameters, which can be read from the word void. So this set of information is sometimes called a prototype, and it is like a label affixed to a function announcing how you can use that function in your program. The prototype says nothing about what the function is intended to do. It is written inside a function, and the interior of the function is called the function body. The function body begins with the first opening bracket here, opening bracket, curly bracket, and ends with the corresponding closing curly bracket. It may sound surprising, but the function body can be empty, which means that the function does exactly nothing. We can even create a function that is lazy. It can be encoded like this: void, then lazy, and then void, then no empty block. This drone provides no result. Its name is lazy. It doesn't take any parameters. The second void, and it does absolutely nothing. The blank space between the bracket. By the way, the names of the function are subject to some fairly rigid constraints. More on this later. So this is the function, right? Composed of the data type, what would be the result, the name of the function, and how many parameters of the function. Alright, okay. So inside the main function body, we need to write what our function is supposed to do. If we look inside, we find a reference to a block named cout. Firstly, note that the semicolon at the end of each line. Each instruction in C++ must end with a semicolon. Without it, the program will be incorrect. So this particular statement says, instruct the entity named cout to show the following text on the screen, as indicated by the dgraph, which specify the direction in which text is sent. You might ask, how do we know that cout will do that for us? Well, we know it because it says so in the C++ language standards. The cout entity, in fact, it's an object, but we don't want to bring up this word too soon, more on it later. Must be fed with something that is intended to be shown on the screen. In our example, the feed is just text. For simplicity, we can assume that strings in the program in C++ are always enclosed in quotes. That way, the compiler recognizes the text that is sent to the user of the program, and the text that is intended to be compiled is translated into machine language. This distinction is very important. Take a look. So here we have the function int main void, and the line above is the main function prototype, which is the int main void. The line above is not a main function prototype, but a string that only looks like part of the source code. Why? Because it is not a prototype because it has a semicolon. It will become a function prototype if we have a pair of curly bracket. The compiler is not interested in what is between the quotes and therefore uh, doesn't recognize such strings as code. How does it work? We can picture it like this. The execution of our main function is suspended, and during that time, cout together with this angle bracket prints the text on the screen. While when the text is printed, the main function wakes up and continues to its activity. The above form of source code is the most natural and perhaps the most easily read by humans, but you're still free to write it in a different way. For example, cout and then double angle bracket. It's me, your first program, and then semicolon. In the C++ language, it is not necessary to write just one statement per line. You can place two statements on the same line or split one statement into several lines, but bear in mind that the readability is a very important factor. However, compilers, unlike humans, will never complain about your style. Okay, we are almost at the end now. There is only one line left in our program. This is return 0, semicolon. This is another statement of the C++ language. Its name is just return, and that is what it does. Used in the function, it causes the end of the function execution. If you perform return somewhere inside a function, this function immediately interrupts its execution. The zero after the word return is a result of your function main. It's important. This is how your program tells the operating system the following. I did what I had to do. Nothing prevented from me from doing this, and everything is okay. If you were right, if you were to write return 1, this would mean that something had gone wrong. It did not allow your program to be performed successfully, and the operating system could use that information to react appropriately. So is that all? Yes, that's it. Let us look again our program and see what's happening step by step. First, we introduce the function name main into our program. It will be executed when you start the program. Second, we made use of an entity name cout inside a main function. It will print the text on the screen. And lastly, the program finishes immediately after printing, indicating that everything you expected to achieve has been achieved. So hopefully it wasn't as difficult as it seemed at first glance. Now let us try to persuade the computer to compute something for us. After all, that is what they are for. So let's go to the next chapter. Let's go to 1.3, talks about integer values, integer variables, and comments in C++ programming language. All right, so how about numbers and how computers see them? Okay, we have 1.3.1. Do you know how computers perform calculations on numbers? Maybe you have heard of the binary system and know that it is the system computers use for storing numbers and that they can perform any operation upon them. We are not going to go the uh, intricacies of positional number numeral systems here, but we will say that the numbers handled by modern computers are of two types. The first is integers, that is the whole numbers or those which are devoid of the fractional part. Second would be floating point numbers, and that contains the fractional part. Right. So this definition is quite simplistic, but good enough for our purposes. This distinction is very important, and the boundary between these two types of number is very strict. Both of these kinds of numbers significantly differ in how they are stored in a computer memory and in the range of acceptable values. Additionally, the characteristic of a number which determines its kind, range, and application is called type. So now we know two types of C++ language, an integer type and a floating point type, which is float. All right, so for now, let us leave the floating point numbers aside and let us consider a question that is maybe a bit banal at first glance. How does the C++ language recognize the integers? Well, it is almost the same as when you are writing them on a piece of paper. They are simply a string of digits. They make up a number, but there is a catch. You cannot include any characters that are not digits inside the number. Take, for example, the number 11,000,000 111,111. If you took a pencil in your hand right now, you would probably write like this: 11111111, or like this: 11.11 dot dot 111, or even like this with the space. And for sure, this makes it easier to read. Of your number consists of many digits. However, C++ doesn't like this at all. You have to write your number as follows without any marks or symbols or punctuation mark. If you don't, the compiler will shout at you. And how do you code negative numbers in C++? As usual, by adding a minus. You can write negative 1111. Positive numbers don't need to be preceded by the plus sign, but you can do it if you want. The following lines describe the same number. We can have a plus sign or without, so it means that we are writing a positive number. For now, we will deal only with integers. We will introduce floating point numbers very soon. There are two additional conventions unknown to the world of mathematics. The first of them allows us to use the numbers in an octal representation. If an integer number is preceded by the zero digit, it will be treated as an octal value. This means that the number must contain digits taken from 0 to 7 range only. 0, 1, 2, 3 is an octal number with the decimal value equals to 83. The second allows you to use hexadecimal numbers. Such number used by preceded by the prefix written as 0x or 0 capital X. 0x123 is a hexadecimal number with the The decimal value equals to 291. So let's have the second slide. A variable is a variable. So the C++ language allows us to write numbers. It probably won't surprise you that we can do some arithmetic operations with these numbers too. Add, subtract, multiply, and divide. Contain your excitement. Well, we will be doing that soon enough, but it's quite normal to ask how to store the results of such operations in order to use them in other operations. There are special containers for that purpose, and these containers are called variables. As the name variables suggests, the content of a container can be varied in almost any way. What does every variable have? A name, a type, and a value. Let's start with the issues connected with a variable's name. Variables don't magically appear in our program. We as developers decide how many and which variables we want to have in our program. We also give them their names, almost becoming their godparents. If you want to give a name to the variable, you have to follow some strict rules. First is the name of the variable can be composed of upper or lower Latin letters, digits, and then character underscore only. The name of the variable must begin with a letter. The underlined character is a letter. Strange but true. Upper and lowercase letter are treated as different. So, for example, at least a little different than in the real world. Alice with a LICE small letter and all caps Alice are the same given names, but they are two different variable names and consequently two different variables. These same restrictions apply to all entity names used in C++. The standard of the C++ language does not impose a restriction on the length of variable names, but a specific compiler may have a different opinion on this matter. Don't worry, usually the limitation is so high that it is unlikely you would actually want to use such long variable names or functions. Here are some correct but not always convenient variable names. We can have I, we can T10, and then exchange underscore rate. Then we have counter, then this to the end of the row. We have the name of the variable, which is so long that you will not be able to write it without mistakes. And we can have underscore. So the last name may be ridiculous from your perspective, but your compiler think it is just great. And now let us have a look at some examples of incorrect names. So we have 10T does not begin with a letter because it begins with numbers. We have adios underscore senorita Signora. It contains illegal characters such as this character and this character. Remember that we are only enable use the Latin letters, and we have exchange rate because it contains space. So instead of space, you can put underscore. Okay, so let's have the third slide. The the type is an attribute that uniquely defines which values can be stored inside the variable. We have already encountered the integer or int and the floating point float types. The value of a variable is what we have put into it. Of course, you can only enter a value that is compatible with a variable's type. Only an integer value can be assigned to an integer variable. The compiler will not allow us to enter a floating point number here. Let us talk now about two important things. First, how the variable are created. Second, how to enter a value inside them. So the variable exists as a result of a declaration. A declaration is a syntactic structure that binds a name provided by the programmer with a specific type offered by the C++ language. The construction of such a declaration is simple. Just use the name of the desired type, then the variable name, or variable name separated by commas if there are more than one. The, the whole statement ends with a semicolon. Okay, so let us try to declare a variable of type int named counter. The relevant portion of the program will look like this. Int counter here. So what is declared by the following fragment of a program? We can have int variable one, then we can have account underscore balance, and then invoices semicolon. It declares three variables of type int name respectively, variable one, account underscore balance, and then invoices. Remember that you are allowed to use as many variable declaration as you need to achieve your goal. That is the example of declaring name of the variable. Okay, so and how do we give a value to the newly declared variable? You need to use the so-called assignment operator. Although this sounds rather mysterious, the operator has a simple syntax and ambiguous interpretation. The assignment operator looks very familiar. Here it is. So equals. Let us look at some examples. Counter equals 1 or assigned to 1. The above statement says assign the value of 1 to a variable named counter, or a bit version, assign 1 to counter, assign 1 to counter. Some programmers use a different convention and read such a statement, counter becomes 1. So we can read this expression, um, assign 1 to counter, or counter becomes 1. Okay, so another example. In this case, the new value of the variable result will be the result of adding 100 to 200, but you probably already guessed that, right? So if you are going to read this, assign 100 plus 200 to result, or result becomes 100 plus 200. Okay, so and now a slightly more difficult example, seeing this a mathematician would probably protest. No value may be equal to itself plus 1. This is a contradiction, but in the C++ language, the sign equals does not mean is equal to, but assign a value. So how do we read such a record in the program? Take the current value of the variable x and add 1 to it and store the result of the variable x. In effect, the value of the variable x is incremented by 1, which has nothing to do with comparing the variable with any value. Take a look at the right side of the screen. You will see a list of words that play a very special role in every C++ language program. They are called keywords or reserved keywords. They are reserved because you cannot use them as names or variables, neither neither for your variables nor for your functions or any other name entities you want to create. The meaning of the reserved keyword or word is predefined and cannot be changed in any way. Fortunately, because the C++ compiler is case sensitive, you can modify any of these words by changing the case of any letter, thus creating a new word which is not reserved anymore. For example, you cannot do this. Int, and then your variable will be int. You cannot do this. You cannot have a variable named int. It is prohibited. But you can do this instead. Int and then capital I of int. The compiler will be happy, very happy, because if you will use that, it will give you an error. So here is the list of keywords in C++ programming language. Let us read it all. Okay, so first is and N underscore EQ, ASM, auto, beat and, beat or, bool, break, case, catch, char, class, compl, const underscore cast, continue, default, delete, do, double, dynamic underscore cast, else, enum, explicit, export, extern, false, float, for, friend, go to, if, inline, int, long mutable, namespace, new, not, underscore EQ, operator, or underscore EQ, private, protected, public, register, interpret underscore cast, return, short, sign, size up, static underscore cast, struct, switch, template, this, throw, true, try, type def, type id, type name, union, unassign, unsigned, using, virtual, void, volatile, wchar underscore t, while zor and zor underscore eq. So these are the reserved keywords in C++ programming language. So now we are going to make some comments. We don't mean comments on either your achievements or our achievements, although we are sure you have many achievements to be proud of. We are referring to other comments, namely comments on the program and inside the program at the same time. The developer may want to add a few words addressed not to the compiler but to humans, usually to explain to other readers of the code how the tricks used in the code work, or the means of the variables and functions, and possibly to store information on who the author is and when the program was written. Good and responsible developers describe each newly created important entity, in particular explaining the role of the parameters of the value modified or returned as results, as well as explaining what code actually does. How do we leave something like this in the source code? We have to do it in a way that won't force the compiler to interpret it as part of the code. The remark inserted into the program, which is omitted at the time of compiling, is called a comment. If we want to be precise, we should say that each comment is lexically equivalent to one space. Whether the compiler encounters a comment in your program, the comment is completely transparent to it. From its point of view, this is only one space. The C++ language supports two ways of inserting comment. We have double slash line comments, and we have slash then asterisk. This is a black comment or multi-lines comment. A line comment discards everything from where the pair of slash signs is found up to the end of that same line. In the C++ language, a block comment is a text that begins with a pair of following characters. Here, first is slash and then asterisk and ends with a pair of following characters. So another one, asterisk, and then this is the closing. This is the closing and this is the opening. The comment can be spanned several times or occupy only one line or part of a line. On the right, you can see an example in which everything from the pair of slash signs on is ignored by the compiler. The line comment can start anywhere on the line. This could be a blank line too with no content at all. So in this example, from the starting with the double slash count, count the number of shift in the middle is considered as comment. Okay, so on the right, you can see an example of a similar comment but introduced into the code using the second method. Any new developer reading the program will be aware of the true meaning of the variable. The developer will write the code faster and it will take less time to understand it. So we have a black comment here. So black comment allows you to comment a multi-line comment or caption. So this is how we write this. So counter variable counts the number of sheep in the meadow is considered a comment. Developers often place a note at the beginning of the source informing when they write the program stating who amended it and why. The note may appear like this. Here, this is the note. So note that despite the complicated structure and the multitude of stars, the condition stating how the comment should be started and finished is fully met. Comments may be useful in another respect. You can use them to mark a piece of code that you currently don't need for what reason. We often do this during the testing of the program in order to isolate the place where an error could be hidden. Okay, so let's have the last slide for this chapter. And for this part, we have just got one more thing to say about comments. Compilers differ in assessing whether another comment may be placed within a single comment. Consider the following program here. We have a comment, another comment here. So the question is, are you allowed to nest one black comment just like int j and int j and then comment inside another black comment? The answer is no. You cannot use such construction in your code. So that is the answer. You cannot nest your comment. So the compiler will give you, the compiler will only read what would be only pair of slash and asterisk. So this is not is prohibited. Right, so let's go to 1.4. It talks about numbers and their operators. So let's have first floating point numbers. A word or 2.0 words about floating point numbers in real life and in C++ language. Previously, we became acquainted with the concept of data type and learned that one of the basic types known in C++ language is the integer type named int. Now is the time to talk about another type designed to represent and store the numbers that have a non-empty decimal fraction. These are the numbers that have a fractional part after the decimal point, and although this is a very simplistic definition, it is sufficient for our purposes whenever we use a term like 2.5 or 0.4. We think of numbers which the computer considers to be floating numbers. So now let's go back to the values we quoted a moment ago. 2.5 looks normal when you write it in the program. Although if your native language uses a comma instead of a point in the number, you should make sure that your number contains points and not commas. The compiler will either not accept it or will misunderstand your intentions, as the comma itself has its own reserved meaning in the C++ language. If you want to use the value of just 2.5, you should write it as shown in the picture. So we have 2.5. So note, once again, there is a point between 2 and 5, not a comma. As you can probably imagine, you can write the value of 0.4 in C as 0.4. Don't forget this simply rule: you can omit 0 when it is only digit in the front of or after the decimal point. In essence, you can write the value 0.4 like on the right, 0.4. For example, the value of 4.0 could be written as 4 point without changing its type or value. Note, the decimal point is essential to recognize floating point numbers in C++, look at these two numbers, 4 and 4.0. You might think that they are exactly the same, but the C++ compiler sees them completely different. 4 is an int and 4.0 is a float. We can say that the point makes a float. Don't forget that. When you want to use any numbers that are very large or very small, you can use so-called scientific. Take for example, the speed of light expressed in meters per second. Written directly, it would look like 3000000. To avoid the tedious job of writing so many zeros, physics textbooks use an abbreviated form which you've probably seen already. 3 point This is 3 multiplied by 10 to the power of 8. It means 3 times 10 to the power of 8. In the C++ language, the same effect is achieved in a slightly different form. Take a look. 3e8, and the letter E is concise representation of the phrase times 10 to the power of, or comes from the word exponent. Note the exponent, the value after the e, must be an integer. The base may or may not be an integer. So it can be a float. Let us see how this convention is used to record numbers that are very small. A physical constant called Planck's constant, denoted as h, according to the textbooks, has the value of 6.6267 times to the 10 to the power of negative 34. If you would like to use it in a program, you would write in this way: 6.6267e, then negative 34. And that's it. Not so hard, right? So that is how we write an exponent or scientific notation in C++ programming language. Let's go back to the floating point values. We already know what a variable is, and we also know how to declare an integer variable. So now it is time to declare variables of a floating point type. We do this using the keyword float, knowing that we can declare two floating point variables named pi. We cannot name it pi because, as you already know, the C++ language freaks out when variable names are written in Greek letters and filled like this, as you can see in the screen: float pi, comma, fill, then semicolon. As you can see, the difference in declaring the integer and float variables is quite small from the syntax point of view. So this difference in terms of semantics is significant, as you can see in the example. Without a little thought, we can figure out that the symbol that performs the mathematical division is a single character slash. Take a look at this code. So we have I is equals 10 slash 4, or divided by 4, and x is 10.0 divided by 4.0. It might be a bit surprising for you to know that the value that will be entered in the variable I is 2, while the variable x will be equal to 2.5. Look at this example carefully because it illustrates a very important difference between these two types of data. So we have integer and we have float. So more precisely, the float will give you an exact number because float enables us to give us the float or the decimal, right? And while in integer, if we are going to divide it and we have some point, it will just round off and give you the whole number, just like here. It will give us 2 only, not 2.5 on the other hand. Right, so Let's have the next slide. Okay, so what happens when we have to convert integer values into float values or vice versa? We can always transform from int into float, but it can lead to a loss of accuracy. Consider the example. So we have declared here int and then I. So float is f. We have updated float and the variable is f. And we have I and it's assigned to 100, and then f is equivalent to I. So that is how to convert float to integer. But on the other hand, it will lead us to loss of accuracy. So after changing from int to float, the value of the variable f is 100.0 because the value of type int is 100 is automatically converted into float, which is 100.0. The transformation affects the internal representation of those values as computers use different methods for storing floats and ints in their memory. Let us consider the opposite situation now. As you have probably guessed, this substitution will result in a loss of accuracy. The value of the variable I will be 100. 25 hundredths has no meaning in the int's world. Furthermore, converting a float into an int is not always feasible. Integer variables, like floats, have a limited capacity. They cannot contain arbitrarily large numbers. For example, if a certain type of computer uses 4 bytes, which is 32 bits, to store int values, you can only use the numbers from the range of -214748364 to 2147483647. So float has its limited capacity. All right, so the I variables is unable to store such a large value, but it is not clear what will happen during the assignment. Certainly, a loss of accuracy will occur, but the value assigned to the variable I is not known in advance. In some systems, it may be the maximum permissible integer value, while in others, our error occurs, and in others, still the value assigned can be completely random. This is what we call an implementation dependent issue. It is the second and the uglier face of the software, portability. An operator is a symbol of the programming language which is able to operate on values. For example, an assignment operator is the equal sign. We already know that it can assign values to the variables. Now, let us look at some other operators available in the C++ language and find out which rules govern their use and how to interpret the operations they perform. Let us begin with the operators associated with the widely recognizable arithmetic operations. The order of their appearance is not accidental. We will talk more about this afterward. An asterisk is a multiplication operator. If you take a look at the code here, you will see that the variable k will be set to the value of 120, while the c variable will be set to 0.625. Okay, so here, okay, so a slash is a divisional operator. The value in front of the slash is a dividend, while the value behind the slash is a divisor. Look at the snippet of the program. Of course, k would be set to 2, k would be set to 2 here, and z is equivalent to 0.5, which is the division between 10 and 5 and 1.0 and 2.0. As you have probably guessed, dividing by 0 is strictly forbidden, but the penalty for violating that rule will come to you at the different times. If you dare to write something like that, the compiler will go nuts. You will get a compilation error, runtime error, or some message at runtime, possibly also a few choice words about your programming capabilities. Okay, the last one was a joke. It still is some cases you won't be able to run your program. As a general rule, you should not divide by zero. So in the following example, the compiler won't tell you a thing, but when you try to execute that code, the result of the operation may be surprising. It's not a number. It's a special feature value named NINF as an infinitive. Generally, this kind of illegal operation is a so-called exception. When you find exception in your program, you should react accordingly. We will discuss this later. So the addition operator is the plus sign, which most of us already know from maths class. Again, take a look at the snippet in the program as you can surmise k is equals to 102 and z is to 1.02. So here, why do we get that answer? Because I, which is equivalent to 10, plus j is equivalent to 2 is equals to 102. And 1.0 x is equals to 1.0 and y is equivalent to 0.02, then we are going to add that because of this operator, then it will give us the number, the result 1.02. The subtraction operator is obviously the minus sign, although you should note that this operator also has another meaning. It can change the sign of a number. This is a good time to show you a very important distinction between unary and binary operators. In the C++ language, there is also a ternary operator. More on that a bit later. As usual, let us get acquainted with a snippet of the program. You can guess that k will be equals to negative 100, while z will be equals to 0.0. Okay, so why we have an answer of negative 100? Because I, which is equivalent to 100, and j is equals to 200, 200 is negative 200, then it will probably give us negative result, which is negative 100, while 1.0 is equals is minus 1.0, then it will give us the result 0.0. In subtracting applications, the minus operator expects two arguments: the left, which is the minuend in the arithmetical terms, and the right, which is the subtrahend. For this reason, the subtraction operator is considered to be one of the binary operators, just like the addition, multiplication, and division operators, but the minus operator may be used in different way. Take a look at the snippet. So here, as you have probably guessed, that the variable j will be assigned to the value of 100. We use the minus operator as a unary operator, as it expects only one argument, the right one. Okay, so I is equivalent to negative 100, and of course, my negative times negative is equals to positive. So it will give us the value of positive 100, or simply 100. The same dual nature can be expressed by the plus operator, which we can also use a unary operator. Its role is to preserve the sign. Take a look at the snippet. Although such a construction is syntactically correct, using it doesn't make much sense, and it would be hard to find a good rationale for doing it. So here we have a plus sign here. So doing that can, or without a plus sign, it is also equal to us to 100. Okay, so here the remainder operator is quite Peculiar because it has no equivalent among traditional arithmetic operators. Its graphical representation in C++ language is percent character, which may look a bit confusing. It is a binary operator, forms the modulo operator, and both arguments cannot be floats. Don't forget that. Look at the example. The k variable is 3 because 2 times 5 plus 3 is equals to 13. And here, so you can see if I is equivalent to 13 and we have a modulo and it is stands for 100. So all we have to do is 13 divided by 5. 5 is equals to 2. Then we have a remainder 3. So the answer would be equals to 3. So we are going to disregard the answer in the division. Oh, and one more thing you need to remember, you cannot compute the remainder on the right argument equals to 0. Can you guess why? You probably remember what we said earlier about dividing by 0. And because division by 0 invokes undefined behavior, the modulo operation, which relies on division, is undefined too. Well, that is what the C++ standard says. We have to accept that. So far, we have treated each operator as if it had no connection with the others. Of course, in real programming, nothing is ever as simple as that. Also, we very often find more than one operator in an expression, and then things can get very complicated very quickly. Consider the following expression. If your memory has not failed you, you should remember from school that multiplication precedes additions. You probably remember that you have to multiply 3 by 5, keep the 15 in your memory, and add it to 2, thus getting the result of 17. The phenomenon that causes some operators to act before others is known as hierarchy of priorities. The C++ language precisely defines the priorities of all operators and assumes that operators of larger or higher priority perform their operations before the operators with lower priority. So if you know that asterisk or the multiplication has a higher priority than plus or in addition, we can figure out how the final result will be computed. The binding of the operator determines the equal of the computations performed by some operators with equal priority put side by side in one expression. Most operators in the C++ language have the left-sided binding, which means that the calculation of this sample expression is conducted from left to right. 3 will be added to 2 and 5 will be added to the result. Now at this point you might be snorting and saying that all children know perfectly well that addition is commutative and it doesn't matter in which order the additions are performed, and yes, you are right, but not quite. Additions performed by the computer are not always commutative, really. We will show you this in more detail later, but for now, be patient and trust us. Since you are new to C++ language, operators presenting a complete list of operators priorities may not be a good idea. Instead, we will show you its truncated form and we will expand on it consistently during the introduction of the new operator. This table now looks as follows. So we have a unary priority, which is plus minus, and then we have multiplication, division, and modulo, plus minus, which is a binary. So note we have gone through the operators in order from the highest to the lowest priority. The difference between unary plus in addition and binary plus in addition is the unary is just a sign which is a negative and a positive number, and the binary is the addition itself and the subtraction itself. Quiz. We want to check if you understand the concept of binding. Try to work through the following expression. Both expression, which is operators, which is multiplication and modulo, have the same priority, so you can only guess the result when you know the binding direction. Are you ready? All right, so what do you think? Since multiplication and modulo have the same priority, you can choose both. Whether, okay, so first we are going to do the multiplication. 2 times 3 is equals to 6, and if we are going to get the remainder from 6 and 5, so we will get 1, right? Because 6 divided by 1 is equals to 1, then the remainder will be 1. All right, so yes, you're right, the result is 1. Can you hear the sounds of trumpet? They are playing for you. Okay, so 1. Of course, we can always use parentheses, which can change the natural order of calculation. In accordance with arithmetic rules, sub-expressions in parentheses are always calculated first. You can use as many parentheses as you need, and we often use them to improve the readability of an expression, even if they don't change the order of operations. Here is an example of an operation of multiple parentheses. Now try to figure out the value given to the slash variable. So what do you think is the answer here? If j and model j is equivalent to 25 modulo of 13, what do you think is the answer? We have 7. We have 12, right? 12 here. Okay, so how about 2 plus k? This is multiplication. 2, we have 26. Okay, so we are going to divide it. 12 divided by, oh, we have I here, so I'm going to use calculator. Okay, so if the answer for j modulo k is 12, and then I'm going to divide 12, I'm going to add I, which is equivalent to 100, and then the answer for 2 times k is 26. Then I'm going to divide it. I'm going to get the result 4.3 something. So since we are using int only, so we are going to round off here and only use 4, and then 4 times 5, we get 20 divided by 2 is equals to 10. So the answer for L is 10. Yes, it is 10. Well done. Right. So here are some operators in C++ language which you won't find in math textbooks. Some of them are frequently used to increment a variable by 1. This is often done when we are counting something, for example, ship. Let us consider the following snippet. In ship counter is equal to 0. Every time a ship runs through our thoughts, we want to the variables to increment like this. Ship is equals counter plus 1. Ship counter equals ship counter plus 1. Similarly, operations appear very frequently in typical programs, so the creators of C++ language introduced a set of special operators for these actions. One of them is the plus plus operator. You can achieve this same effect in a shorter way, ship counter plus plus. It looks much more elegant now, doesn't it? So instead of using yes, ship counter equals ship counter plus 1, you can use ship counter plus plus. It will have the same effect. Similarly, you can also decrease the value of a chosen variable. For example, if we can hardly want for our holiday, our mind does the following operation every morning. Days until holiday equals days until holiday minus 1. You can write this in a more compact way, which is holiday days until holiday minus minus, or decrement. Sorry, but now it is time to introduce a few new words. The plus plus sign is called the increment operator, and the minus minus sign is called a decrement operator. So we have shown you that plus plus and the minus minus operator after a variable. Specialists in the syntax of programming languages would say that they are used as postfix operators. However, both operators can be put in front of a variable as prefix operators like this: plus plus, ship counter or minus minus days until holiday. The effect is exactly the same. Ship counter will be increased by 1, days until holiday decreased by 1. There is a fairly significant difference as described by the names of this operator. Ladies and gentlemen, here they are. They may seem a little strange at first, but they will grow on you. Let us discuss the effects of these operators. So first, operation variable and minus minus variable affect, increment or decrement the variable by 1 and use its value already increased or reduced. Operation variable plus plus and variable minus minus, the effect would be used to original or it is unchanged, where variables used and then increment decrement by the variable by 1. So that is the difference. The behavior of these operators justifies the presence of the prefix or pre before and post after in their names. Pre because the variable is modified first and then its value is used, and post because the variable's value is used and then the variable is modified. Take a look at these two simple examples. First, the variable I is set to 1. In the second statement, we see the following steps. First is the value of I will be taken as we use the post increment operator. The second is the variable I will be increased by 1. In effect, J will receive the value of I1 and I will receive the value of 2. Because as you can see, I is assigned to 1 and 1 is assigned to I, and then if since we are using I plus plus, so this means increment, then 1 plus 1 is equals to 2, then J will be equals to 2. Things will go a bit differently now. The variable I is assigned the value of 1. Next, the I variable is incremented and becomes 2. Next, the increased value is assigned to the variable j variable. Is assigned to the j variable. In effect, both I and j will be equals to 2. So that is the difference on the post and the pre. Okay, so let's have the next. So look carefully at this program. Let us trace its execution step by step. The I variable is assigned to the value of 4. We take the original value of I, which is equals to 4, multiply it by 2, assign the result of A to J, and eventually post increment the I variable, it's now equals to 5. And 3, we pre-decrement the value of J, it is now equals to 7. This reduced value is taken and multiplied by 2, and the result 14 is assigned to the variable I. What else do you need to know about the new operators? Well, firstly, their priority is quite high, higher than the asterisk, slash, and the percent operators. Secondly, they have the right side binding. Our priority table is currently as follows. So here we have a unary, this is an updated priority table. We have the here's the increment and decrement, or plus plus and minus minus. We have a higher priority. Okay, so now it's time for the next set of operators, ones that make a developer's life easier. The ones we have already described deal with addition and subtraction of 1. However, we often need something other than addition or subtraction, or we want to use a different value. We can use this operator when we want to calculate a series of successive values of powers of 2. We use this expression when our herd is extremely numerous. So we can use that operators, that is shortcut operators, or we can say that ship counter equals plus 10. Here in the language, there is a short way to write this operation. You can write them as follows. So I times equals 2, or ship counter plus equals 10. So instead of writing ship counter equals ship counter plus 10, you can write ship counter plus equals 10. Or instead of writing I equals I times 2, you can write it I times equals 2. Let us try to represent a general description for such operators. If op or op is a two-argument operator, this is a very important condition, and the operator is used in the following context. Variable equals a variable, then operator or op expression. It can be simplified and shown as follows. So variable operator equals expression. Take a look at the example here. Make sure you understand them all and relax, because we still have a lot of work ahead. So instead of writing this, you can write them using this. So instead of using I once again, so since it is equals to itself, or you are going to use once again here in the assign operator, after the assign operator. So instead of that, you are going to put the next operator here to front of the equal sign, and just remove I, and then proceed the other to the other elements, just like I plus equals 2 times j. Okay, so here we already use var and var here after the assignment operator. So instead of that, you are going to remove this and move the slash before the assignment operator. So we have var slash equals 2. And we have RAM is equals to RAM modulus 10. So if you are going to make it simplified, you are going to put the modulus before the equal sign or the assignment operator, then 10 here. Okay, so how about this one? So all we need to do is take a look in the same variable, which is j. So after that, take a look in the next operator to the variable. Okay, so this is minus, then get that operator and put that in the front of the assignment operator, just like we did here. Okay, so right, so that is how we simplified those two argument operators. All right, so let us continue running the code, our first program on the NetBeans, Apache NetBeans. So all we need to do, since Apache NetBeans IDE is defaultly for is a compiler used for Java. So all we need to do is make it or add a plugin for C or C++. So all we need to do is click the tools, and after that plugins, and then all we need to do is available plugins, and available plugins, check the C or C++ here. Okay, so if there is no C++ category in the available plugins tab, all we need to do is first is go to settings, and then make sure that all of this NetBeans 8.2 plugin portal, distribution plugin portal, and third-party libraries have the check in the checkbox, right? So after that, all we need to do is go back to available plugins, and then check if it is C or C++ category is now on the options. So after checking that, then install. So here, going to uh, click the button next, and then accept, and then install. Okay, so let us wait to download the plugin in order for us to run our program. So maybe in the middle of or after the validation, you can see this verify certificate. To verify or um, continue the installation, you can press continue here. So it will continue installing the plugin. So guys, after installing the plugin, then the IDE will prompt you a restart now an option, and please restart your IDE for the changes will reflect on your updated IDE. So now I as you can see already the source file or the source code already read by the IDE. So now I'm going to run this program after it will be configured this, and after that then the run button will enable me to run my program. Alright guys, so it gives us an error here, resolve missing native build tools. So all we need to do is install another thing, and that is called Sigwin. Go to sigwin.com and choose whatever version you have. If you are using 64-bit, then click this one. And then if you are using 32-bit, then you use this setup 86.exe. Then since I use this one, click this and it will prompt you to a download. Then run. Then it will give you uh, an update about the installation progress to Sigwin setup. And after that, you will uh, prompt to a choices if you are going to download it from the internet and use or download or install that from a local disk and use C and then from the internet, and then it will prompt you here, and then just click next. Okay, so as you can see here, will give us this review and confirm changes, then push the next here, and it will download the Sigwin files. So it will give you a list of download links and choose whatever you want. You can choose the first one, second one, and wherever it will give you the same result. Okay, so here's the progress. Let us wait. So for you guys to know what or the complete installation about the IDE connected to C or C++, you are going to follow this one, this um, this link. Okay, I'm going to send it to you. So I'm going to send it here. Okay, so that would be the instructional or step-by-step procedure on how to um, install a complete guide for NetBeans IDE. So first you need to install NetBeans IDE and then JDK, what we have done earlier, and then the Sigwin or MinGW. So I choose Sigwin because it has the same result. So if you want to use Qt with Windows, you must install MinGW. So since I'm not using Qt, then I will use Sigwin. So take note here for Windows, the NetBeans or C or C++ module has been tested with compiler from Sigwin and MinGW. You should install either Sigwin or not, but not both. Okay, so now let's check the progress of our setup. Okay, it's still 9%, 13%. Okay, so let's continue reading it. Okay, so that would be a perfect guide in installing the NetBeans with C++ in order for us to, you know, prevent errors when running our program. Okay, so let us wait for is, so here it after completing the installation, you will give an option if you can create an icon on your desktop or icon in your start menu. So I'm going to erase this, uncheck that, and then finish. All right. So before we can run this, uh, all we need to do is restart the IDE. Okay, so I'm going to close this and reopen this after. All right, guys. So after restarting, it will definitely run your program. So now that concludes the first session, part two of the Diverse Node Mobility Front-End Development Program, and wait for the part three. All right, so have a good day and goodbye.